right, good morning. I'm going to start all over again because when I first started to record this, I was recording the screen and not the camera, so you couldn't see what I was doing. So we're going to start all over. We're going to take a look at the law of sines. And the law of sines follows a different type of patterns than our law of cosines. We still use these for acute, right, and obtuse triangles, but we have to have information that follows the pattern of angle, side, angle, or angle, angle, side. Now, these are the two we're going to study today. You can have the pattern side, side, angle, but this one is known as the ambiguous case, and we're going to that's a whole other discussion that we're going to have later. So we're just going to focus on these two right now. And what I like about the law of sines, it's proportion. And you're relating a side length to the sine of the angle across from it. So when you look at it's much more simple to solve, not nearly as much, involvement as the law of cosines. So what you're doing is you're just setting two ratios equal to each other to find either the unknown side or the unknown angle. All right, so to start off with, we're going to take a look at this triangle giving us the information in the pattern of angle, angle, side. So I went ahead and labeled the information given. We have a side length of 32 feet. Angle A is 30 degrees and angle B is 45 degrees. So we're going to find the missing sides and the missing angle. And I went ahead and just started off with finding the missing angle. That was easy peasy. These three angles add up to 180. So we're just going to subtract 45 degrees and 30 degrees from 180, and what's left over is the measure of angle C. Obviously, this is not drawn to scale. But that is what we come up with when we do the math. So we now have angle C. To actually set up and solve the proportion, what we need to look for is we need to look for a complete ratio, meaning we need to know a side and the angle across from it, and that's going to be our scale factor, so to speak. And so since we actually know the measure of angle A and the side across from it, this is what we're going to use. All right, so that's going to be kind of our scale factor that we start off with. So make a note. Start with finding a complete ratio. Start with finding a complete ratio. All right, so what we're looking at is angle A and side BC. All right, so we've got angle A and side BC. All right, now when I go to set up my proportion, I'm going to start off with the sine of angle A, which is 30 degrees, the sine of 30, and I'm going to compare it to the side across from it, which is 32. I'm going to set that equal to, now I just have to pick one of my other angles. So if I start with angle B, and I say the sine of 45, if that's what I set it equal to, then I need to use and solve for side AC. So I'm going to put AC right here. All right, so now once I've got my proportion set up, all I have to do is cross multiply and solve. So I'm going to go ahead and multiply across here so that we've got the sine of 30 times AC. And then cross multiply this way. We've got 32 times the sine of 45. All right. Then the last step is to divide both sides by the sine of 30. Remember, the sine of 30 is an actual number, and basically the sine of 30 is the sine of pi over 6, which is 1/2. So we're basically dividing by 1/2 or 0.5. And I'm just going to do all of this in one swoop. I don't even need to put stuff in the calculator yet. Just get it all written out and then we can do it all at once. All right, so now then, take your calculator, make sure you're in degree mode, and we're going to type in 32 times the sine of 45, enter, and then divided by the sine of 30. And you should get a length of 45. All right, so we've got about 45.3. What are we measuring in? Feet. So AC has a length of 45.3 feet. All right, we got that side done. And I put, let's see, I think I messed up on this label up here. That's supposed to be an AC, and so we've got 45.3 for that side right there. All right, now we want to find the length of AB. So let's find side AB. Find side AB. Okay, so to find this side over here, we know it's across from an angle that's 105 degrees. So we are going to use 105 degrees, the sine of that, with this side. But we're still going to use our completed ratio, sine of 30 to 32. Now, some of you may be thinking, well, hey, since we found the length of this side, couldn't we use this as our completed ratio? Technically, you could, but I just want to remind you that we did round our answer. And so since we rounded our answer, if we use that number to find further information, our answers are going to be altered just a little bit. It's always safest to go with what you were originally given because those answers are exact. All right, so we're going to set this up as the sine of 30 degrees. And it is over 32. Then we're going to look over here at the sine of 105 and compare it to AB. All right, once we've got that, we're going to cross multiply, get all that good and out of the way. So AB times the sine of 30 equals 32 times the sine of 105. All right, last step is to divide by the sine of 30. All right, plug all of that into your calculator. 32 divided by the sine of 105. And then divide. Oh, did I say divide? No, that's not what we want. 32 times the sine of 105. Then divide by the sine of 30. All right, and we should get a side length of 61.8. AB is equal to 61.8, and this is feet. All right, so now we have completed and found the missing sides for our triangle. We have completed our triangle measurements. All right, that was angle, side. Again, much quicker, much easier than the law of cosines. So let's take a look now at our other case, which is angle, side, angle. All right, angle, side, angle. We've been given the information that we have, let's see, what have we got? AB has a length of 30 meters. Angle A is 22.5 degrees. And angle B is 96 degrees. So as you can see, this follows the angle, side, angle pattern. And we're going to solve for the rest of this triangle. Very easy. We've got two angles. Subtract from 180. We'll get angle C. So we'll do that one first. Get the easy one out of the way. angle C is equal to 180 minus the sum of 96 and 22.5. So then we've got angle C is equal to 61.5 degrees. Yes, got that one done. All right, now I'm going to go ahead and put that in here, 61.5 degrees. Now, since we did that, we have a complete ratio right here. Without finding that angle, we didn't have a completed ratio. So the completed ratio is the sine of 61.5 to 30. So this is what we're going to use as our model. All right. So first of all, let's find side A, or side BC right here across from angle A. Find BC. So what we have is our scale factor. The sine of 61.5 is to 30, as the sine of 22.5 is to BC. Cross multiply. BC times the sine of 61.5 is equal to, cross multiply, 30 times the sine of 22.5. And then we'll divide both sides by the sine of 61.5. Get all of that written out. Okay, and then we should get the answer of, let's see, 30 times the sine of 22.5, then divided by the sine of 61.5, 13.1. So 13.1, and we're measuring in meters. So we've got 13.1 meters. All right. 2 down, 1 to go. The next side we're going to find is AC. This side right here across from our 96-degree angle. Find AC. What we have, I'm going to use my completed ratio right here. Now, I know we used this angle, we found this angle, and we had to round it, and we're using it. You know, that was our only choice, though. We didn't have any way around it. So sometimes that will happen. I just try to avoid using numbers that I've rounded whenever possible. So we've got the sine of 61.5 over 30, and that's going to be equal to the sine of 96 over AC. Okay. Cross multiply. AC times the sine of 61.5 equals 30 times the sine of 96. Divide both sides by the sine of 61.5. And let's see what we get. 30 divided by sine of 96. Why do I keep hitting divided by? Dadgummit, I hope I didn't do that earlier. Did I do that earlier? Make a stupid mistake earlier? No, it looks like I actually got it. Okay, let's see. 30 times the sine of 96 divided by the sine of 61.5. All right, and we get 33.94 4, so 33.9. AC is equal to 33.9 meters. All right, so what you should have grasped from this lesson is when you're using law of sines, you got to follow the patterns of angle, side, angle, 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 side. And when you are trying to set all of this up, you got to make sure that you find a completed ratio. If you have the angle, angle, side pattern, you have a completed ratio to start with before you even find your missing angle. If you're using the angle, side, angle pattern, you have no completed ratio. You have to start off finding that missing angle so that you have a complete ratio to use as your scale factor. And then cross multiply and solve. You guys got this. Have a good day.